Hello students! Welcome to Math&Magic. For today's video, I will teach you how to simplify radical expressions. By definition, radical is an expression that uses a root, such as square root, cube root, and others. The expression 5 square root of 18x squared is an example of a radical expression. Here, the term 18x squared is called the radicand. That is the term inside the radical symbol. This one is the radical symbol or the radical sign. This is used to denote square root of a number or higher order root of a number. Moreover, in this expression, 2 is the index. That is also the reason why we call this as square root. This implies an index of 2. Also, as you can notice, the number 2 in the index is not written. It is because the base value for an index is 2. If the index is higher than 2, one should write its value like in the case of cube root, fourth root, and others. Lastly, 5 is the coefficient of the radical expression. Now, when simplifying radical expressions, one must remember to factor and express the radicand in terms of the value of the index. As an example, let us simplify the radical expression 5 square root of 18x squared. Here we first need to focus on the radicand and write the factors of the coefficient 18 in terms of its prime. 18 is the same as 3 times 3 times 2 or 3 squared times 2. Then x squared. Next, we will look at the exponents of the terms in the radicand. If it is a multiple of the index, then we could extract a value outside the radicand. In the given, 2 is the index. Question is how many 2 can we get from the exponent of 3? Obviously, it is 1. 2 divided by 2 is 1. Here we will extract 3 outside the radical sign. In the case of 2, since its exponent is 1, and we cannot get 2 from 1, we will retain 2 in the radicand. For x squared, again we can get 1, 2 from the exponent 2. So we will extract x. Now we will multiply all the terms outside the radical expression. That will be 5 times 3 times x, then square root of 2. 5 times 3 times x is 15x, square root of 2. Thus, the simplified form of 5 square root of 18x squared is 15x, square root of 2. Another example, express 2 cube root of 16x raised to 5, y raised to 6, and z raised to 7 in simplest terms. Again, we will focus first in the radicand. Here we will rewrite 16 in terms of its prime factors. That is 2 times 2 times 2 times 2 or 2 raised to 4. Next, we will observe the index. Here that is equal to 3. After that, we will determine how many 3's we can get from the exponents of the terms in the radicand. For 2 raised to 4, we can rewrite that as 2 cubed times 2. Thus, we can extract 2 from the radicand and the remaining 2 will retain in the radicand. For x raised to 5, that can be written as x cubed times x squared. Hence, an x will also be extracted while the remaining x squared will retain in the radicand. Doing the same for the remaining terms, for y raised to 6, there are exactly 2 3's from y raised to 6. Thus, y squared will be extracted. Lastly, for z raised to 7, that can be written as z raised to 6 times z. Again, there are 2 3's from 6, so z squared will be extracted. Meanwhile, z will retain in the radicand. Just like in example 1, all terms outside the radical sign will be multiplied. The radical expression can now be written as 2 times 2 times x times y squared times z squared. Then cube root of 2 times x squared times z, or that is 4xy squared z squared cube root of 2x squared z. Therefore, the simplified form of 2 cube root of 16 x raised to 5 y raised to 6 z raised to 7 is 4xy squared z squared cube root of 2x squared z. For our third example, simplify the radical expression square root of 27 a raised to 5 b raised to 4 all over the square root of 12 a cubed. For this item, we have to remember the quotient rule in radicals. This rule states that if a is greater than or equal to 0 and b is greater than 0, then the nth root of a over the nth root of b is the same as the nth root of the quantity a over b. This implies that when the indices of two or more radicals are the same, then division of radicands can be performed. Now going back to example number 3, since the two radicals are both square roots, we may rewrite this as the square root of 27a raised to 5b raised to 4 all over 12a cubed. Now we will simplify the radicals. We will rewrite 27 and 12 in terms of their prime factors. 27 can be written as 3 times 3 times 3 or 3 cubed. Meanwhile, 12 can be written as 2 times 2 times 3 or 2 squared times 3. Observe that these two factors can be simplified since both have a common factor of 3. Hence, 3 can be cancelled out. It will be 3 squared over 2 squared. For variable a, applying quotient of powers rule, the exponents of a in the numerator and denominator will be subtracted. It will be a raised to 5 minus 3 or simply a squared. Then copy b raised to 4. Next, we will observe the index. Here that is equal to 2 since we have a square root. After that, we will determine how many 2's we can get from the exponents of the terms in the radicand. For 3 squared, there is exactly 1 2's in the exponent, thus 3 will be extracted. For the denominator 2 squared, just the same, we can get 1 2's in the exponent, so a denominator of 2 can be extracted. For a squared, a will be extracted, and lastly, b raised to 4, b squared will be moved outside the radical sign. Hence, the simplified form of the radical is 3 over 2 or 3 halves ab squared. For our last example, simplify the radical expression, the cube root of the square root of the quantity 729 over x raised to 6. For this item, there are two methods that we can use. First is by simplifying the innermost radical until it reaches the last radical sign. Here we will perform first the innermost radical symbol, square root. The square root of 729 is 27. Then for x raised to 6, that is x cubed, since we can get 3 2's from raised to 6. Next is to perform the cube root. Cube root of 27 is 3. For x cubed, that is x. This brings us to the simplified form of the radical, which is 3 over x. Another method is by multiplying the indices. Then perform the operation. In the given, cube root of the square root of quantity 729 over x raised to 6, indices are 3 and 2. Multiplying the values, product is 6. Thus, the radical expression can now be written as the 6th root of the quantity 729 over x raised to 6. Rewriting 729 in terms of its prime, that is 3 times 3 times 3 times 3 times 3 times 3 or 3 raised to 6. Now we will perform the same operation as that of the earlier. We will count the number of 6 being the index that we can get from each term's exponent in the radicand. For 3 raised to 6, 3 will be extracted, and for x raised to 6, x will be moved outside the radical sign. Hence, 3 over 6 is the answer. Thank you for watching. God bless.